Hello, my name is Sandeep and welcome you all to my channel Sanju's Kerala Banking Classes. In today's session, we are going to learn inequality in logical reasoning. Normally, beginners do attempt this kind of questions in 2 to 3 minutes, but in today's session, we are going to learn how to attempt this kind of questions within 50 to 60 seconds. Yeah, within 50 to 60 seconds, we can solve 5 questions from this topic. So here comes the topic. In today's session, we are going to learn concept as well as we will work on question set. So before move to questions, I would like to tell the concept of inequality. Basically, ഞാൻ point A and point B draw ചെയ്താൽ that is point A is on left side and point B is on right side, and in between point A and point B, if I draw a line, so there is no meaning of any direction, so there is no proper direction if only a line is drawn. But at the end of a line, if I draw an arrow like this direction, so that means now my direction is from left to right side. Along with line, if I draw an arrow key, that means it will show the direction from left to right as well as from right to left side if I draw the arrow key at the left end. Same as if I draw the arrow key at the both end, then that means I can move from left to right side as well as right to left side. So this is basically the two-end process. In our concept, there is no meaning of this line, only the arrow key is useful. So in inequality, if this structure is visible, now onwards we will say that A to B. So here A is the starting point and B is the destination point. Same in second line. The line is not important, the direction of arrow is important. So if I remove the line, the structure is like this, and that means my starting point is B and my destination point is A. So I can say that from B to A. In third, that is like a bit confusing, but rather saying A equals to B, now we will say like we can move from A to B as well as B to A. So this is basically the two-way path or two-way direction. So there are basically the 5 types of conclusion. First is from A to B, and second is also from A to B. So normally inequality പറയുമ്പോൾ we will say like A is greater than B, A is greater than and equals to B. So now for both the structure we will say from A to B. So A is starting point and B is destination point. Vice versa, this two will say like from B to A, and the last one is from A to B as well as from B to A. So it is two-way direction. Actually this one we will use in coded inequality, but you have to remind this structure. Right now this is not useful in normal inequality, but in coded inequality we will use this structure to solve equation in easy way. So in this structure, greater than will comes over here, greater than and equals to over here, less than over here, less than equals to over here, and equals to at the middle. Conclusion എന്തൊക്കെ require values ഉണ്ട്, only that values we will check in statement part. So basically conclusion is our direction and statement is our path. Like my direction is from Kerala to Jammu Kashmir, and in between that direction the path will be like Kerala, Karnataka, Maharashtra, Gujarat, Rajasthan, and so on. So in today's concept, this diagram is important. We are not going to read like A greater than B, we will going to read like from A to B. This two is from A to B, and this one is A to B as well as B to A. Okay, so there are valid statement and there are invalid statement with our conclusion. So നമ്മളുടെ conclusion like A to B വന്നാൽ only E greater than the sign അല്ലെങ്കിൽ less than the sign വന്നാൽ in our path all these three values, these three signs are valid. In second point, if greater than equals to or less than equals to, then in our statement only these two signs are valid. Greater than or less than sign is not valid. And in third one, this is from A to B or from B to A. So in our statement only equals to are allowed. Less than, greater than, less than equals to, greater than equals to, this both are not allowed in our path. So in question first, so as we discussed, conclusion first is C to A. So I can move from C to D and then D to A. Okay, and I have to check now the sign. Like this sign is there, then these three symbols are valid. So as we discussed, our first conclusion is true. Now move to conclusion number 2. Conclusion number 2 says from A to C, that is A is starting point and C is destination point. So from A means there should be one starting point or outgoing from A, and towards C means there should be incoming from any other value. So if I check A to C, then here is my starting point, here is my starting point A. So in this path or in this statement I cannot move from A to any direction, like there is no outway or no outgoing from A. There is only incoming from D to A, but there is not a single output from A to anywhere. So I cannot move from A to any values. So my second conclusion is false. Second conclusion is false. So the answer is conclusion 1 is true. Conclusion 1 is true. So here comes question number 2. So my first conclusion says P to Q. So that means my starting point is P and my destination point is Q. So I can move from P to L, but from L I cannot move to any other direction or any other values. So there is a path from P to L, but I cannot reach my destination, that is Q, using any other path. So my first conclusion is false. Second conclusion says from Q to M. That means Q is my starting point and M is my destination point. So if I check Q in my statement, then Q is over here. So I cannot move from Q to N or Q to anywhere else. So directly I can say that this conclusion is false, because in conclusion it's saying like Q to M. That means there should be one opening or one starting point from Q, but there is no outgoing way from Q, only incoming from value N is there. So conclusion 2 is also false. That means the answer is neither conclusion 1 nor 2 follows. Question number 3. In question number 3, conclusion first says V to S. That means from V and destination is S. So if I move to V, then I can move to V to X as well as V to U. But my destination point is S, so I have to choose this path. So I can move from V to U, then equals to means I can move from U to T as well as T to U. So yes, the path is V to U, U to T, but there is no path from T to S, so I cannot go to my destination part. So this conclusion is false. So basically, first thing is we have to check that is there any outgoing from my starting point, and second thing is there any incoming at my destination point. Like if I check V, then there is outgoing from V in both direction, V to U and as well as V to X, and destination point is S. So I have to check is there any incoming point towards S. So no, there is no incoming towards S. So without traveling my path, I can directly cross this kind of conclusion. Now move towards next conclusion. Conclusion number 2, V to T. Yeah, as we traveled before, so we can move from V to U and U to T. And as we discussed in our previous slide, that if this kind of sign is there in conclusion, so all these three signs are valid. So from V to T direction we can move to V to U and then U to T. So this conclusion is true. But some student may have doubt, the sign is reverse, then how it is true? So the concept says, like if I write A to B or A is greater than B, and if I reverse the value or reverse the position of value, then I cannot draw the same symbol. Like here it is A is greater than B and here it is B is greater than A. So I cannot write B is greater than A. I have to use this symbol. That means if element interchange their position, the symbol should also reverse. Okay, so reverse value of greater than is less than, and reverse value of greater than and equals to is less than and equals to, and there is no reverse value for equals to. So this was the basic structure we discussed before. So here the answer is only conclusion 2 is follows. Question number 4. Conclusion first says from M to Q. So my starting point is M. If I check my path or my statement, I cannot move from M to anywhere because there is incoming from N to M, but there is no outgoing from M. So without wasting time, I can directly strike out this conclusion. No need to check complete statement, only the required value is needed. So move to conclusion number 2. Conclusion number 2 says M to Q. Here also my starting point is M, but I cannot move from M to anywhere. So this conclusion is also false. Here also some students may have doubt like this can be either case, or some says like this can be neither case. So the answer is neither. It is not either case. Like in a classroom, normally നമ്മളെ പഠിപ്പിച്ചിരിക്കുന്ന concept is like these two symbols വന്നാൽ either case ആണ്. But no, here the opening end is towards M, and here also the opening end is towards M. So the concept of this two structure says like if the opening is towards different element, then it can be either case. Like if I say my conclusion was M to Q, and the second was Q to M here. So first is M to Q, so I cannot move from M to anywhere, so indirectly this conclusion would be wrong. Second, Q to M, so I can move from Q to P, then further traveling is not possible. So I can say that second conclusion is also false. But the thing is, here the opening of symbol is towards M, and here the opening of symbol is towards Q. Open part is towards Q and this open part is towards M. This would be the either case. This would be the either case. So now question 4, in our question 4, this is neither case. Move on to question number 5. So hope now you can solve these questions. So conclusion first says Y to V. Y is my starting point and V is my destination point. So here I can move from Y to X, so there is outgoing from Y. Now I have to check V, is there any incoming or not? So yes, there is incoming from W. Yeah, so now I have to check this path. So I can move from Y to X, then X to W, then W to V. So yes, there is direction from Y to V, and for that there is a path from y to x and x to w and then w to v. So yes, we can move from y to v. So conclusion first is true. Conclusion second says w to u. So my starting point is w and my destination is u. So if I say there is outgoing from w towards w to v as well as w to x, but my destination point is u, so I have to move in this way. So here we can check that there is incoming from v to u. So yes, we can further check this conclusion. So we have to move from w to v and then v to u. So yes, again this statement is true, because if in my conclusion if symbol is this, then all these three symbols are valid in my path. So this one is true. Question number 6. Question number 6 says, which of the following expression is true if the expression this is definitely true? So there are 5 options and we have to check that which option is true. So conclusion first says k to z. Directly I can strike out number 1 conclusion because there is no outgoing from k to anywhere. Second conclusion also says k to s. Here also the starting point is k and there is no outgoing from k to anywhere. Third one says n to k. So my n is here and k is here. So if I check outgoing, then there is outgoing from n to z, and if I check incoming, then there is incoming from t to k. Now if I check my path, then I can move from n to z, but I cannot move from n to s or further. So I can move from n to z, then there is no movement from z to anywhere else. So conclusion third is also false. Conclusion number 4. Conclusion number 4 says s to z. So here is my point s and here is z. So yes, I can move from s to n and then n to z. So I can move from s to z using this path s to n and n to z. So this one is true conclusion, as s to z, if this symbol is there, then this and this, these 3 symbols are valid. Only important thing is this symbol should be there in my path. That means minimum one this kind of symbol should be there, else this will not true. Next question, question number 7. So there is a set of conclusion and I have to check that from A to J traveling is true or not. So my starting point is A and my destination point is J. So previously we discussed, if in our conclusion this symbol is there, then these 2 symbols are valid. as well as this symbol should be there, like minimum one symbol should be there. But this symbol is not valid. So if in conclusion part this symbol is given, so this 2 greater than equals to and equals to are valid, and that 2 minimum 1 greater than should be there, or 1 less than should be there. But greater than or equals to is not valid if in my conclusion greater than equals to or less than equals to are there. Okay, so here I can check from A to J. So my starting point is A and destination is J. So in first conclusion, if I check, there is no outgoing from A to anywhere. So I cannot move from A to any values. So first conclusion is false. If I move to second conclusion, then A is here, and here also I cannot move from A to anywhere. So this conclusion is also false. See how fast you can solve this kind of question using this concept. Moving to third question. So I can move from A to C, then C to Q, Q to X, X to N, and N to J, and J is my final destination point. So yes, I can move from A to C, C to K, C to Q, Q to X, X to N, as well as N to J. So as we discussed, if this kind of symbol is there, then these two symbols are valid, and yes, this conclusion is true. But the important point is, if in between this path this symbol is there, so you cannot travel from A to J. Yes, there is path from A to J, but you cannot travel from A to J, because previously we discussed that if this symbol is there, then this kind of symbol is not valid in our path. So third conclusion is true. Now we have to check fourth and fifth also. So in fourth, I can move from A to M, and then further I cannot move from anywhere. So fourth one is false. Here also there is no outgoing from A, and also there is no incoming towards J. So this conclusion is also false. So my answer is option number 3. Option number 3 is true. Question number 8. Normally E kind of questions student will get confused because of this comma separated values. So normally beginners a single line equation would happen, then they will check the conclusion. But in our concept, no need to convert this in single line. Like my starting point is B and my destination is S. So here my destination point is S, and in statement there are two values indicated as S. So I have to check both the values. So my starting point is B, and there is only one B, but here I can see that I cannot move from B to anywhere. So there is only incoming from N to B, but there is no outgoing from B to anywhere. So I can say that conclusion number 1 is false. Conclusion second is F to G, that is F is starting point and G is destination point. So here is my point F. I can move from F to N. So I moved from F to N, then there is 2N, so I can move from any N. So I move from F to N, then N to A to S, and S to G. So my path is like this. I moved from F to N, then N to A to S, and S to G. So yes, I can travel from F to G. So yes, if this or this symbol is there, then minimum one symbol should be there. So yes, there is one symbol matching this. So this conclusion is true. So here is question number 9. In question number 9, conclusion first says U to B. So my starting point is U and destination is B. So I can move from U to J, J to S, S to C. I can move till C, but from C cannot move towards B. So there is no path so that I can travel from U to B. So my first conclusion is false. Second conclusion says M to J. So here is my M, there is outgoing from M, and here is my J, and there is incoming from U. So if I move from M, I can travel from M to B, B to C, but further from C I cannot move to any other values. So this conclusion is also false. So the answer is neither 1 nor 2 is true. Question number 10. Now I hope that you are getting this concept and you are able to solve this question. Stop the video, try to solve the question, and then play the video and check that your answer is right or not. So here conclusion first says R to F. So that means I have to check R and F both. Here is R and here is F. So there is outgoing from R, but there is no incoming towards F. So no need to check this complete statement. I can directly strike out conclusion first, as there is no incoming towards F. See how easy is this concept. Question number 2. Conclusion 2 says from S to G. So here is point S and here is G. So I can move from S to N, from S to N, then from N to G. So this conclusion is true. Now the important thing is either cases. In conclusion first, it says my start point is P and destination is T. So here is the P and T is over here. So I can move from P to R, then R to T. So there is path. Like P to T, I can move from P to R, then R to T. But as we discussed before, if in my conclusion this symbol is there, then these three symbols are valid. But the important thing is this symbol should be minimum 1. So minimum 1 symbol should be there in my path, and there is no such symbols in my path. So conclusion first is false. Okay, hope you are getting this concept. So if this kind of symbol, then this should be minimum in my path. If this kind of symbol, then in my path minimum this symbol should be there. And if in conclusion equals to a symbol, then in complete path only equals to are valid. Conclusion number second say P to T as well as T to P. I can check in both way. So I can again travel P to R and then R to T. So as we discussed, if in my conclusion equals to is there, so in my path there should be equals to symbols, no other symbols are valid. So there is path, but the symbol is not validating the path, so this conclusion is also false. But if I see this kind of conclusion, so this is basically the either case. So the concept of either case is here. As we discussed before, like this too is conclusion part. Okay, so if in my conclusion greater than and equals to are there and both the conclusion are individually false, greater than and equals to, and both individually false, then I have to combine these two symbols and make a third symbol, that is greater than and equals to. So using this combined symbol, I have to check that I can move from my starting point to destination point or not. Same if in my conclusion these two symbols are there and both the conclusion is individually false. The thing is, both the conclusion should be false, otherwise it cannot be either case. So if both the conclusion is false, then I have to combine both the symbol. So if I combine both the symbol, I will get less than and equals to symbol. So using this symbol, I have to move from my starting point to destination, and if I can move from my starting point to destination, then this kind of conclusion is either case. Like here, my conclusion first was false, and as well as my conclusion second also false. But in conclusion first, the symbol was greater than, and in conclusion second, the symbol was equals to. So if I combine both these symbols, so I will get greater than and equals to. So now I have to use this path. I have to check this direction is true or not. So again, my starting point is P and destination is T. So here I can move from P to R and then R to T. So yes, I can move from P to T. Now I have to check the symbol. So now the symbol is verifying, or the path is valid. So this kind of conclusion is either case. Second condition, if first conclusion is greater than and the second conclusion is less than equals to, and both are false, as well as less than and greater than equals to, if this kind of conclusion are there and both the conclusion are false, then directly we can say that this kind of conclusion is either case. Okay, so we will discuss further in questions, and this symbol is the important one. So remember this symbol, because basically this symbol we will use in encoded inequality. So question 12, we can say that A to C. So yes, from A there is outgoing, I can move from A to B, B to C. So yes, I can move from A to C, but my symbols are not satisfying my path, because if this symbol is there, then minimum this symbol should be there in my path. So it should be minimum 1, but there is no such symbol, so conclusion first is false. And if I check conclusion second, here also I can observe that there is no equals to in my path, so conclusion second is also false. But as we discussed before just now, that if this kind of condition are there, that both the conclusion is false, then we have to combine this kind of symbols and make this one. Now using this symbol, I have to check that I can move from A to C or not. So yes, now I can move from A to B as well as B to C, and yes, the symbol is also satisfying or valid. So this should be either case. This should be either case. So question number 13. Here also conclusion first says from D to A. So I can move from D to C, and C to B, and B to A. Here also there is path, but the valid symbol is not there, so I cannot travel from D to A. So my first conclusion is false, and also the second conclusion, because if equals to is there, then in complete part there should be only equal signs are valid. So conclusion second is also false. But if I check, I can combine both these symbols. So if I combine both these symbols, I will get less than and equals to symbol. So now I can move from D to A, and also my symbol is valid. So yes, I can say that this both is either case. Now conclusion, question number 14, conclusion number 1. Conclusion number 1 says A to G. So I can move from A to B, then B to C, and C to D, D to E, E to F. But from F I cannot move to G. So my first conclusion is false. In second conclusion, it says G to A. So if I check second conclusion, so I can move from G to F, but further I cannot move to any other values. So this conclusion this conclusion is also false. But this is not either or case, because as we discussed, this kind of symbols or conclusion are either cases, but here the symbol is not validating to either case, so this one is neither case. So question number 14 is neither one or 2. Question number 15. Question number 15 says A to G. Same question is there, only the symbol is changed. So as we can see that both the conclusion is false, because I cannot move from A to G as well as G to A. So as we discussed before, if this kind of symbols is there and both the conclusion is false, so yes, this kind of conclusion should be either cases. So either 1 or 2 is true. Question number 16. This is the important question, because normally this kind of questions are asked in exams. Normally out of 5 questions, 1 question should be like from this kind of pattern. So my first conclusion says U to S. So my starting point is U and destination point is S. Then I can move from U to R. Then I can move from R to S. So I can move from U to R, then R to S. But the symbol is not validating in my path. So first conclusion is false. There is path from U to R and R to S, but the symbol is not satisfying, because in my path this symbol should be minimum 1 symbol should be there, but there is no such symbol, so conclusion first is false. Conclusion second. Conclusion second says R to S as well as S to R. So R is here, yeah, so I can move from R to S. But as we discussed, if equals to is there in my conclusion, then only equals to is allowed in my path or statement. So individually second one also false. Conclusion number third, that says from B to S. So yes, I can move from B to R, then R to S. So now also I can travel from B to R and R to S, but here also the issue with symbol. So symbol is not validating as minimum. This symbol is not there in my path. So this third one is also false. But the important thing is this case is either case. Now students will ask, like, there is no matches in values, because in both conclusion S is common but R and P are not common. That is true, but if I check this P to R or R to P, actually the symbol is equals to, that means p is equals to r or r is equals to p. Like if I assign p equals to 5, so by default r will also be 5 only. That means instead of r I can use p, as well as instead of p I can use r. So here I can use r instead of p. Now you can see that if this kind of conclusion is there and individually both is false, then I have to combine both this symbol and make a third symbol, and then if I check, then there is a path and also the valid symbol. So this both conclusion second and third is either case. So this one is most important. So here is the question of the day, and actually I will not solve this question number 17. You have to answer me the question in comment box and suggest the answers in comment box, like conclusion first is true, second is true, third is true, fourth is true, or fifth is true. So post your comment and we will discuss this question in our next video. Thank you.